Okay, so now we've made it to the next section, which is the type conversion. So let's do a little review first. What did we learn in the last section? We learned about strings and numbers and the type of, to know what type of data type it is, what type of value we're dealing with. Get your head wrapped around what values are. We introduced you to the term expressions. You need to understand that. And so as we go forward, I'm going to continue to reiterate and reinforce what we've already learned. So here in the type conversion, we're going to go a little bit further. Now, also, if you're watching this video and you're not a part of the cohort, the curriculum is in the description. The link is free. Anybody, you can share this with your friends and family. Anyone who wants to learn about coding and they just want to see if they like it or if they may find a passion for it, share the videos with them and share the curriculum with them. It's a great resource. Okay, so let's get into type conversions. Sometimes it is necessary to convert values from one type to another. A common example is when a program receives input from a user or a file. In this situation, numeric data may be passed to the program as a string. Now, this is to make sense later on when we get into read line sync, because what this means is that inputs automatically convert everything. Everything is a string. Once you put something into an input field, it automatically defaults to a string. But that's what you may not want that. You may want it to be an actual number. So this is where type conversion comes in. Also too, I'm going to show you the difference between the type conversion and the primitive data types. This sometimes confuses people, so we're going to kind of dig a little deep on this. So let's get into it. JavaScript provides a few simple functions that will allow us to convert values to different data types. The function number and the string function will attempt to convert their arguments into types, numbers and strings, respectively. We call these type conversion functions. You want to understand this. Now, the number function can take a string and turn it into an integer. Let's use this in the action. Let's see this in action. Okay, so what we have here, we're reading this, we're looking at this from our high level view, but we want to think like the compiler. When this console.log, which this is an object, console is an object, log is a method. How do I know that? Because it has parentheses. Let me show you this. Let's inspect so you can understand what I'm saying. So I'm gonna go over to the console, I'm gonna refresh. Now here, I'm gonna copy this over to the clipboard and I'm gonna paste it in. Now, what I mean by that, if I go ahead and this is what it's going to look like to you when you first type it in. All you're just going to do is type console.log with the parentheses. Nothing may not be there. This is the syntax of it. This is why we say anything that has a parentheses is a method. Now, this dot actually means something, and I will explain that later. But nevertheless, let's go back over here and let's delete that, and then I'm going to paste back in what we had originally. So I'm gonna paste that in, and so if I run this, what did it do? It converted this string number. It was a string. Now it's a number. The quotations is gone, and now we ask what is the type of number. It tells me that it's a number because this number is a function. Understand the difference. This is where the confusion comes in at. The primitive data type string is lowercase, string. The function string is capital string, and it has a parenthesis, the same with a number and the same with Boolean. They're going to be capital letters. That's how you know that you're dealing with a method or a function. Also, you need to see the parentheses. Those are identifiers to help you identify what you're looking at. If it's just a lowercase string, which is a primitive data type, that's immutable, but we notice that the number and the string functions are mutable. The data can change. We're manipulating it. Get the little nuance there. Now, what happens if we attempt to convert a string to a number and the string doesn't directly represent a number? Let's look at that. You already see the output right here. It says not a number, but we're going to explain to you. Let me read a little bit more, and I'll read it and then I'll explain a little bit more of what's going on here. This example shows that a string has to be syntactically legal number for conversion to go as expected. Example of such strings: 34 or -2.5. If the value cannot be clearly converted to a number, then NaN will be returned, which stands for not a number. Now, this is where another part of the confusion is going to come in at, and I want you to understand something here. The confusion here is because you're looking at it as a human. You see 23 bottles, but the machine doesn't see that. What it sees is a binary number. It sees that that opening quote has a binary number assigned to it. That 2 and that 3, that's a real legal number because that is assigned to a binary code. But that B is another assigned to the number B in the ASCII table. Now, let's look at that for a second. I'm going to open up a new tab here, and I'm going to type in up here ASCII, ASCII table. I want an ASCII table. And now I'm going to go to the ASCII table. Let's look at this one and see if this gives me what I'm looking for, if it makes it simple for me. All right, so here's the ASCII table right here. Notice here we have the decimal, the hexagon, the binary. We broke that down to you. Now, what's important to understand here is that everything has a value assigned to it. This is an HTML entity over here, but notice that when I get to the number 20 or number 2, if I get to the number 2, it's going to give me an actual binary number. So this is the binary number right here for the number 2, right here, 10. That's the code for 2. So in our curriculum, what happens is, what the compiler does is searches the database so quickly, and it knows that the 2 is a number. It recognizes that as a number, so that could actually be converted. But because it's inside of a string, it's a sequence of characters. Everything inside of those quotes is considered the value. So that's why 23 bottles is going to give me back NaN. So let's go in here. Let's inspect. Let's go to our console. Let's clear that out. I'm going to copy that in, paste it in, and then guess what? I see console, and I get not a number. Now, if I go back up, and all I got to do, let me delete the bottle part. And now let me run it. It converts it to a number. So you have to think like the compiler. That's where the confusion is going to come in at. Because if you keep reading the program as a human, you see it. You see what it says. You know that there's a 23 there. But to the compiler, it doesn't see 23. It sees a binary number. It sees a hexadecimal. It sees 01 for 2. It sees 0 for 1, 01 for 1. And when you get into the binary table, it'll make more sense. And I'll try to reinforce it as we go forward. Now, NaN is a special value in JavaScript that represents the state of a not being a number. That's another key word you need to understand: state. We're going to use that a lot. The state of something. We will learn more about NaN and other special values in later chapters. The type conversion function string function turns its arguments into a string. Remember that when we print a string, the quotes may be removed. However, if we print the type, we can see that it is definitely a string. So here we converted this number to a string string, this other number to a string, and then we get type of, which is string. So what is it telling me? What is so different about it? It's because this is color coordinated. Every tool that you use may not do that, but when it's white like this, technically we're saying it's a string, but don't rely on that. Use type of to make sure it lets you know what it is, that it is a string. That's the best, safest way to know. Now, we want you to check your understanding. Always check your understanding. Now, we made it to the end of this particular section. We're going to go into the next section, which we're now going to get into some more foundational things. Remember, the more you do, the more you improve. Bookmark this, go back over it until it makes sense or enough sense. But don't get stuck there. Keep moving forward. All right, see you in the next section.